If you're looking for some help with number 3 from the partial fraction assignment, well, you've come to the right place. So let me help you to kind of see the plan. So x to the 4th over x minus 3 cubed. Okay. Sometimes people see different things first. So very common, students will notice that the denominator has a repeated factor. The truth is, if you think about the factors of x cubed, you actually have 3 repeated factors, to which is going to require us to use a step-up method. Now, let me share with you that 100% that is true. By the time we're done with this problem, you're going to have to think of this as a over x minus 1 to the first plus b over x minus 1 to the second. See how we're stepping up until we get to c over x minus 1 to the third. Yes, again, eventually you're going to have to think about that. But to be honest, we have something else that we have to think about first. This is an improper fraction, right? The top is bigger than the bottom. So whenever you have an improper fraction, you have to actually divide first. So how are we going to take x to the 4th divided by x minus 3 to the third? Well, very carefully for sure. It turns out that you're going to have to expand the x minus 1 to the third in order to get this long division set up correctly. So most students will just multiply the 2 binomials, or I should say 2 of the binomials. Once you get your answer to that, then you're going to have to multiply the last binomial. So I'm not going to tell you what you get here, but you're going to end up with some type of term to the third, plus or minus some type of term to the second, plus or minus some type of term to the first, and then you will end up with some type of just number. So very carefully make sure you expand x minus 1 to the third, and then you're going to take that polynomial and you're going to long divide it into x to the 4th. Now here's the thing, you're going to need some placeholders in order to get this long division to work out. So we need a 0x to the third, we need a 0x squared, we need a 0x, and you probably even want to have a regular 0. Now if you do this long division correctly, it's only going to take 2 steps. It's not a big shocker that we're going to end up with some type of x in this spot. You end up doing the long division so that you can end up with another set of numbers, and finally there'll be just a number, a plus or minus some type of number, which again will give us another step, and finally a remainder. Now your remainder, I'm not going to tell you what it is, but it will be some type of term that is squared, plus or minus some type of term to the first power, plus or minus just a number. And remember that that remainder does end up then creating, finally creating the fraction that is the numerator to your fraction, which remember is still over, it's still over x minus 1 to the third, which now is when technically we end up with the idea of a over x minus 1 to the first, plus b over x minus 1 squared, plus c over x minus 1 to the third. Again, we have to step up to that. So this is what you're going to solve for a, b, and c. Last thought. Remember this dividend that you got up here, x plus or minus c? Well, that's like the whole part to your partial fraction decomposition. So when you write your final answer, yes, you're going to find a, b, and c, but for perfection, you're going to want to make sure that you include the whole part. Then you can add in your fractions that you're going to end up, again, with a over, b over, and c over for your final answer. That is your final decomposed polynomial. All right. Hope this is helpful. Go get number 3 correct.